Okay, so in this video, we're talking about section 1.7. This is the section on inequalities. So far, we're working our way through this chapter 1, solving lots of different types of equations and seeing some applications of those. Last section, we saw like other types of equations and special cases. So this section, we move on to the inequalities. So an inequality means you've got a less than or a greater than sign. So a statement not exactly equal to, but an interval of answers. For example, x is less than 3. So on a number line, that means wherever you want to designate 3, and in this book uses a parenthesis to designate, there's no line under this, we're not including the endpoint. So less than 3, we would graph it like this, and so darkening the arrow even to show it's all the numbers strictly less than 3. If it was x is less than or equal to 3, that's the or equal to, we would use a bracket, corners, and do it like that. That designates that you're including the endpoint. Some books use open and closed circles. This book uses parentheses and brackets. But it means the same thing. Parentheses mean not including, just strictly less than. Line under it means it also includes the endpoint or equal to. To write this in interval notation, you write how far does it go to the left. We'll call that negative infinity. It just keeps going in the negative direction to infinity, comma to the right to 3. We always use a parenthesis on infinities because we cannot touch or include infinity. The last number of infinity doesn't exist. So we would write it like that. For this one, we would say negative infinity, comma, to positive 3, isn't it? With a bracket and a parenthesis there. So these are inequalities. Another example, let's do a greater than. If we did greater than, let's say -1, we would graph that by saying this way, turn your parenthesis greater than direction, designate -1, and then greater than will go to the right. And then we would call that -1 to positive infinity that way. And then, of course, if the line is under it, we use the bracket. All right, so that's what we're dealing with in this section, the inequalities. There's some special rules for how to deal with different types of inequalities. We're going to start with the linear, the regular linear, just like we did linear equations, but there's going to be one new rule with it, with inequalities. Quadratic, same thing. We'll solve quadratics like we've learned to in the past, but we're going to add on another rule for it. And then rational, how to handle fraction inequalities. So we're going to kind of revisit some old topics, but now with the inequality rule. So the first one we'll talk about, and you can follow along in your note packet, is the linear. And in your notes, the book talk, the way the book would say it, is if you have a statement of inequality, an A less than B, you can add a C to each side. It will not change the inequality. It's still a less than. So you can add, which also means subtract. You can add or subtract to each side of the inequality, just like we have an equation, and it still stays balanced. You can also multiply, but there's a stipulation here. And what it says, this is true if you multiply by a positive number. If C is greater than 0, it's still going to stay less than. But if C is less than 0, if C is a negative number, when you multiply or divide, in this case, multiply or divide kind of go together. They're related operations. So multiply and divide, when you do that by a negative, if C is less than 0, it will flip that inequality. All right, and that's what this narrative is on your handout as you're following along. But this is what it looks like in an example. Let me show you. If we had 3x less than 9, a simple inequality, we could divide by 3 to solve it, like we would an equation, and nothing really happens. It stays a less than. It doesn't flip the inequality. As long as you're doing operations like, let's say even 3x plus 4 less than 7. If we were solving that, we would throw the 4 across the line. We can add and subtract without messing with the inequality symbol. And we can multiply and divide. But if we multiply or divide by a negative, it would flip the inequality. So none of this really affected it. We did these just like we would any other equation. The difference comes in if we were doing negative 3x less than 9, for example. To solve this, we have to divide both sides by negative 3. Dividing by a negative would flip the inequality. And then 9 divided by negative 3, and that would be your answer. And that's what you would graph. Greater than negative 3 goes to the right. No parenthesis, no line under it, so we use a parenthesis to positive infinity. All right, so let's try that. We've got an example on your handout. And again, these are the linear examples. And the rule for linear, really the only new thing about inequalities is if you multiply or divide by a negative, you're going to remember to flip the inequality sign around the opposite way. All right, so let's see if that happens here. So I'm solving along like I would any other linear equation, distributing, combine any like terms, so 15 and 1 can be combined. Variables are on both sides of this, so I need to collect the variable terms. So the 2x is going to move across the line. Again, none of that hurts a thing. 16 goes the other way, so minus 16. So 3x minus 2x is 1x. Nothing I've done would flip the inequality, and 5 minus 16 is negative 11. And so that one is just like solving an equation with the inequality symbol. Nothing about that caused the inequality symbol to change. Less than or equal to negative 11, we'll turn that way with corners, a bracket. Less than goes to the left. And then that would be the visual of our solution, negative infinity to a right point of negative 11. Okay, now there's another example below. Let's look at it. We'll do one now where we do have to flip the inequality to compare that. So on the next example on your paper, we see negative 2x minus 2 greater than 1 plus x. So here, there's really no distributing, there's no fractions. We're ready to start throwing terms across the line. I would bring this x over to the left, making it minus x. Bring the minus 2 to the right, making it plus 2. Negative 2, negative 1 makes negative 3x. Again, nothing so far has flipped the inequality. 1 plus 2 is 3. But now, here's what's going to happen. When I solve, I have to divide both sides by negative 3. By dividing by a negative, divide or multiply by a negative to solve, flips the inequality. Oops, flip it the other way. Then 3 divided by negative 3 is negative 1. And that would be your answer here. Less than goes this way, negative 1. In interval notation, we would call that negative infinity to negative 1. That would be our final answer. That represents everything we should be able to put in the original problem that works. Any number in this interval, say we take a test point like negative 2, if we plug that in for x, it should make the original problem true. That's what we're always doing when we're solving, finding what's supposed to work in the original. So you could test point that. All right, next up you have a U-try. As always, please pause the video and try that on your own before I reveal the answer. So distributing is needed here. There are some like terms, negative 15 and 1, that can be combined on this left side. The variables need to be brought to the same side. Now you might be thinking, shouldn't I bring my variables to the right side? And you can. That's always okay. You can go either direction. But since there's an inequality, you would have to read it backwards. You have to read it from x's point of view. So I usually on these will just stay with the left side so I can read it from left to right. Although I can show you the other way as well. So I would bring the 2x to the left. Negative 3 and negative 2 makes negative 5x's. Still a less than or equal to. 6 and 14 is 20. Now, because I have to divide, and it always is on this last step if we wind up flipping the inequality. On the last step, divide by -5, dividing by -5, that is what flips this around to a greater than or equal to, and then 20 divided by -5 is -4. We should always write these in interval notation as well as maybe graph it. When you're doing your homework, it'll say the form that it wants it in. So I'll just show both of these forms. There's the graph, -4 and then greater than or equal to. Because the equal to line is under it, I have a bracket, or the one with corners. In interval notation, we write how far does it go to the left, should be listed first in order, and then how far does it go right, listed second, the infinity. And the infinity always has a parenthesis. All right, next up, we're going to do three-part inequalities. So still on the linear idea, but it's going to have, instead of just one inequality, it's got two inequalities. So notice this. You've got a double problem, really. We call this a three-part inequality. What we want to do is try to get x alone and in the middle and see what x is between two endpoints. So it won't be an infinity, it'll be a closed interval with endpoints. So whatever I do to one part, like right here, +4, I want to do that to all three parts. There's three parts, one, the middle, two, and then the right, three. Three parts. So when I add 4, I do it to all parts. 0 and 4 is 4. -3 and 4 is 1. Then to finish this, I need to times by 2. Divided by 2 and times 2 will clear that fraction. So times all three parts by 2. It cancels that out, leaving just the x. I did not multiply or divide by a negative, so nothing gets flipped. 4 times 2 is 8. 2 times 1 is 2. So notice it's a closed interval. It's saying x is between these two endpoints. X is between the number 2 with 2 included, 2 with the bracket, and then strictly less than 8. And you could check it. Any number we put in, including the 2, up to right before 8, put in the original problem, should then solve it. So a closed interval this time. One bracket, one parenthesis, and that can happen. All right, so you all have one to try below that, so please do get ahead of me and pause the video and do that. All right, so once again, I've got a three-parter. So in the middle, that needs to be distributed. So it'd be -6x. -6 times -1 is +1. Oh, +6, isn't it? And then less than -2. So we've got the three parts to keep balance. To solve for x and try to get x in the middle, you want to know x is between two endpoints. So we want x alone and in the middle. We want to get rid of this 6 by minusing 6 to all three parts. That gives us 1 minus 6. -2 minus 6 is -8. Then to get rid of the -6 that's multiplied, we divide by -6 on all three parts. This is going to cause those inequality signs to flip, though. Dividing by a negative is what causes that. Dividing or multiplying by a negative. So a negative divided by negative makes that positive, but flips that. That cancels, leaving the x in the middle. This one also flipped, and that reduces to 4/3. So once again, a closed interval. This is saying x is between. It's greater than 4/3, but it is less than 5/6. So that puts it in a closed interval between those two values. All right, so all that was really new on this one was for linear, any linear with the inequalities. You solve it pretty much like you did all your linear equations. You should clear your desk, clear your fractions, do whatever you want to clean each side up. And then on the last step, if you have to divide or multiply by a negative, that flips the inequality. And then also we're having to graph our solutions and write it in interval notation. So that's the new part. Otherwise, it's just kind of repeating. And you'll see we kind of do that in algebra class. We build on old things. So we're definitely building on what we learned about linear equations and then adding in a new step. In the next video, we'll move up to the quadratic. How do we solve quadratics when when they have an inequality symbol on them. And you'll see we're basically going to solve them like we always did, but we have like a last step on it as well. All right, so we'll see that in the next video.